Alright guys, this is a review of our piecewise functions test that we did. If you do want to retake this test, no problem. You will need to watch this video of me going over all the problems, and then I'll just give you a different version of it if you want to retake it. So this will be the answers to our test and how we would get everything here. And thank you guys for watching. Alright, here we go. Okay, the first part is really just evaluating these piecewise functions. We've got two different sets of piecewise functions here. We have f of x, and that's going to be important for identification later. And then we have our graph, which is g of x. Right? So number one, evaluate each of the following values using f of x above. Should be g of x in here as well, but here we go. If I have f of 0, so 0 is going to be my input into my f function. So since I just have one function here, my f function, I'm only going to be using this piecewise function right here. I'm not even going to look at my graph because I only have f. Right? So with 0, we need to see which domain 0 satisfies, right? And so we're going to do this for each one, and whatever domain that 0 satisfies, that's when we're going to use a specific equation that's accompanied by it. So 0. Is 0 in between -8 and -6? No. Is 0 in between -6 and 0? Well, technically, here's 0 right here, but since there's no equal sign underneath this inequality, so that's not going to work, because that means that it does not include 0. So finally, our bottom domain is yes. We have x is greater than or equal to 0, so that is the domain that matches our input. So then we move right to this equation, and that equation only, -x plus 1. So -x plus 1. Now we're going to substitute now that 0 into the x. So -0, which really isn't a thing, it's just 0. 0 plus 1 is 1. There's our final answer. Okay. All right, I'm going to speed it up just a little bit now since I got that explanation done with. We have f of 10. Well, let's see, which domain does it satisfy? Well, it's not negatives. It satisfies this bottom domain again because 10 is greater than or equal to 0. So I'm going to be using my -x plus 1 again. Plug in 10 into the x. -10 plus 1, that is -9. All right. All right, -6, here we go. -6 does not satisfy the bottom domain. It's not greater than 0. There is a -6 in the middle domain, but there's no equal sign underneath, so we cannot use this domain or equation. Let's look at the top one, -8 less than x less than or equal to -6. So we found our domain that matches our input. So now we use this equation, 6x minus 4. Plug in that -6 into the x. We have 6 times -6 minus 4. 6 times -6 is -36. -36 minus 4 is -40. Okay, now we have composition of functions. So g of f of 1 and then f of g of -2. So we're going to be using our graph now. So as we stated during class and instruction, we start from the inside out. So we only focus on f of 1 for the very first one. We totally ignore g right now. So we use f of 1. All right, we're back to our f functions over here. 1 satisfies which domain? Well, 1 is greater than 0. So we're going to use the bottom domain and bottom equation. So -x plus 1, -x plus 1, plug in 1 for x, -1 plus 1, which is 0. Now that 0 becomes my input, my new input to the g function up here, because once we work from the inside out. The point is to get my answer of f of 1, and that y value of f of 1 immediately becomes the input into my g function. So whatever answer we get from the inside, we use as our input for the outside function, which is g right now. So let's look on our x-axis. That 0 is x, right? Well, here's 0 right there on the x-axis. Where's my only other y value? My only other y value is -1. So -1 is my final answer. Okay, here we go. So we use our g function first, g of -2. Here we go. So I'm going to use my graph. My input is -2, which means my x is -2. So on the x-axis, I'm going to go to where x is -2. Where is my only other y value that I have? Oh, it's right up here at 3. So that 3 now becomes the input of my f function, right? I got 3 from g of negative 2, so the y value is 3, but now I move on to making that my input or my x value for the f. All right, so f of 3, there's a theme here. We keep on using this bottom equation here. 3, check the domains, is greater than or equal to 0, so we use our negative x plus 1 equation. Plug in 3 for x, negative 3 plus 1, that is negative 2. And there's how we do the first part of the evaluating. Okay, and now we are moving on to graphing. There we go. All right, we are supposed to fill in the table with values below that will help us correctly graph our piecewise function. Use the appropriate arrows and open and close dots where necessary. So we are basically taking our 3-segment piecewise function, plugging in x values, finding the y values. F of x, that just technically means y. And then we're going to graph 3 different segments in our coordinate plane. We have 3 different equations, 3 different domains. We're going to have 3 different graphs over here on the coordinate plane. And now what I've done before. Okay, so the f of x means y. There we go. All right, so for our x values, we really have all the x values that we need right here per domain and per equation, right? So we know that the first part of this domain has a negative 5 and a 0. Now one might be an open circle or a closed circle, but we're going to be using these values for our x's. And we only need 2 points to really graph a line. So negative 5 and 0 for our first segment. And I'm going to just divide it off into 3 parts. That's fine. And then we use 0 and 3. So it's telling us what our x values are. And then 3 and 6 for our last one. And now simply to find our y's, right, to find the y value of our coordinate point, we take my x value here, negative 5, and all we do is just plug it into the equation. Right? Take that negative 5, plug it into the x, take the 0, plug it in the x, and then we have each respective y value. Plug in negative 5 into the x. Negative 5 plus 6 is what? Positive 1. And then we have 0, plug it into the x. 0 plus 6 is 6. Just like that, we have our coordinate points. If we have an x value and a y value, we can plot it. So let's go to the x. X of negative 5, 1, negative 2, negative 3, negative 4, negative 5. And then the y value of 1. So it's going to be up here. Now we have to be careful. Let's look at right here. It is just a less than sign. There's no equal sign underneath. So that means it is an open circle. It is an open circle, meaning it does not include that part of the domain. Right? So let's go to 0, 6. 0 on the x, 6 on the y. There is an equal sign underneath the 0. So I'm going to plug that in. It's an closed circle. All right? And then guess what? We have our 2 points. We just literally connect those dots. And we have the first part of our graph, just like that. All right. Let's use the next x values, 0 and 3. Plug in 0 for x. Plug in 3 for x. Get our y values and graph, just like we did. So negative 2x plus 1. If I plug in 0 into the x right here, negative 2 times 0, well, that's just 0. 0 plus 1 is positive 1. We have our first point of our second segment. Let's plug in 3 for x now. I'm going to write this down here. If I have negative 2, instead of the x, I'm going to put 3 because that's what I'm plugging in, and then plus 1. Negative 2 times 3 is negative 6, and then negative 6 plus 1 is negative 5. So that's going to be my y value for my second point. And then just like that, let's graph it. I do like to sometimes draw circles and lines by the table just to tell me if I have an open circle or a closed circle. That negative 5 from our first was an open circle. That 0 from our first was closed. So let's look at 0 and 3 here. Well, since they're only less than signs and they're not an equal sign underneath, both of these points are going to be open circle. So when we graph these points, just make sure they're open circles. So let's do that. 0, 1, well, 0 on the x, 1 on the y, open circle right there. And then 3 on the x, and then negative 5 on the y, 1, 2, 3, 1, 2, 3, 4, 5. open circle there, and I have my graph just like that. All right. So let's look at the last one. My 3 value is going to be a closed circle whenever I graph it. My 6 value is going to be an open circle. So graph that. And now let's find out our y's. So plug in 3. Uh-oh, look at that. Whenever we don't have an x value, we technically don't even have an equation. This just means that my y value automatically is -7. That's nice. We don't have to plug it in anywhere. So y value of -7. It doesn't matter what my x value is. It could be 3, it could be 4, it could be 5, it could be 6, and so on and so on. My y value is always -7. So this means we're going to have a horizontal line whenever we graph it. So I have my coordinate points, 3, -7, 6, -7. Let's graph it. 1, 2, 3, and then -7, 1, 2, 3, 4, 5, 6, 7. It is a closed circle because of my equal sign under here that I already put by my table. Closed circle there, and then 6, -7, 1, 2, 3, 4, 5, 6, -7, 1, 2, 3, 4, 5, 6, 7. That is, an open circle, and then I literally just connect those dots, and I got it. Okay. All right, so there is a review of graphing piecewise functions and evaluating piecewise functions. Thank you guys for watching and reviewing.